Hello, and welcome to the very first best practices video for kindergarten. In this video, I will share what one can expect to see and hear during a visit of a mathematics kindergarten classroom. Let's get started. Here you will see a few questions to think about throughout this video. Take just a moment to figure out all of the ways to decompose or break apart the numbers 8, 7, and 6. How many different ways are there to decompose each of those three numbers? When you think about the different ways, do you notice a pattern in the number of ways to break each number apart? Do you think that pattern would continue if you were to decompose the numbers 5, 4, and 3? This is a pattern that we as adults with lots of number sense would internalize. However, when our students are building their number sense in kindergarten, they won't notice these patterns without our questioning and support and really understanding of the standards expectations. Throughout this PowerPoint, I want you to think about that very last question on the slide. How can we help out students discover the patterns of decomposing numbers? Let's go ahead and dive in to see some thoughts. In this unit, we are focusing on composing, which means putting together, and decomposing, breaking apart, numbers to 10. This unit of study will encompass the following learning goals. Students will count forward to and backwards from 10 with and without objects. So that means with tools as well as just being able to count on their own. Students will also learn how to read, write, and build a number when given a number or a specific quantity. So if I ask, can you show me the number 7, they would be able to write it as well as build it and show it with tools, or they could draw a picture. Students will also represent numbers with pictures and objects. So again, any number up to 10, they should be able to show with various objects as well as pictures. Students will also learn how to compose, which is put together, and decompose, break apart, numbers up to 10. These learning goals can be found within the STEMscopes parent letter as well. These learning goals that we just read might sound abstract to some people, so let's dive in a little bit to see what should we see happening in the classroom to support our students' understanding of those learning goals that we just went through. Students should be using tools throughout this unit, not just at the beginning. Students start with using tools and then they move into using coloring or drawing pictures of what they did with their tools. As students move deeper into the unit, they will be asked to show their thinking with pictures and numbers to represent the situations that they are solving. Starting with tools, then moving into pictures, is part of the concrete, representational, and abstract approach, also known as the CRA approach. With CRA, we want to show the connections between the tools, the pictures, and the numbers, and what they represent within the problem-solving situation. So if we look at this example that is showing 3 red and 3 blue, those are actually showing 3 red cupcakes and 3 blue cupcakes in a problem-solving scenario. A student can show the cupcakes with tools, just like they're showing in the picture. They could show it by drawing a picture that has 3 blue and 3 red cupcakes, just like it looks like they were doing in the picture as well. And also there's space on that page that if that student is ready to represent with numbers, they can also show 3 and 3 to equal 6 in numerical form. We want to make sure students are not rushed through these stages, but are supported by seeing other students' representations that can be connected to their own thinking. So if I am in the concrete stage and I showed my thinking with tools, but somebody else in the classroom showed their thinking with pictures or with numbers, we could put those two examples together under the Elmo, and we could ask, where do you see 3 red cupcakes in with the tools? Where do you see 3 red cupcakes with the picture or with the numbers? You'll notice a mini copy of the Mathematical Thinking and Reasoning Standards poster in the corner. This is to remind us that the MTRs are how students demonstrate their understanding of mathematics. These explorations by students in the classroom could demonstrate MTR 1, which is actively participate in effortful learning, MTR2, which is demonstrate understanding by representing problems in multiple ways. MTR5, which is use patterns and structures to help understand and connect math concepts. And MTR7, which is apply math to real-world contexts. So now that we saw a demonstration of what we might see in the kindergarten classroom, what do you think we should hear in the kindergarten classroom? The questions we ask as teachers dictate the learning and the types of conversations that will happen with our students. Here are a few examples of math chat questions that are found from STEMscopes with each Explore section. Notice that these questions are mostly open-ended questions. These questions will elicit deep student thinking and explanations from our students. The conversations from these types of questions could demonstrate MTR1, which is actively participate in effortful learning, MTR4, which is engage in discussions that reflect on math thinking of self and others, and MTR6, which is assess the reasonableness of solutions. So thinking about now that we know what we should see and hear when we're in kindergarten classrooms, here are some vocabulary that we should also hear coming from the teacher as well as the students. So as our students engage in the explorations and deepen and discuss their learning throughout the unit, we should hear math learning being used by both the teacher and the student. Here's a list of some possible vocabulary terms we should hear throughout the unit. This list can also be found within the STEMscopes parent letter. Here we have compose, which we've already talked about, which means to combine or build a number. Decompose, which again we've already talked about, means to break apart a number into smaller pieces. One-to-one correspondence, we haven't quite talked about too much. That means when a student is able to touch an object as they say the correct counting number that matches. So within this unit, they're also going to be practicing their counting as they're putting together and taking apart those numbers. And then counting, which is the ability to count with or without objects in an organized way. Throughout the unit of study, we will see multiple opportunities for students to demonstrate their learning through student journals and exit tickets that correlate with each Explore, as well as show what you know tasks. Students may also use fluency builders and games to practice and elaborate on their understanding throughout the unit. Learning tasks such as these provide the teacher with many opportunities to formally and informally assess the student's understanding throughout the unit. Activities such as these can demonstrate MTRs 1, which is actively participate in effortful learning, MTR2, demonstrate understanding by representing problems in multiple ways, MTR3, which is complete tasks with mathematical fluency, MTR4, which is engage in discussions that reflect on math thinking of self and others, and MTR5, which is use patterns and structures to help understand and connect math concepts. Oh, and I forgot MTR7, which is apply math to real-world contexts, which we definitely want students doing throughout this unit. As we visit classrooms, we may want to ask students questions to better gauge their understanding of the current content. Here are a few different questions that we could ask to get a better understanding of what students know. These example questions and more can be found on our website, mathsmarts.com, or by clicking on any of the benchmark links within our instructional guides. These three questions, one example, if I have 2 counters, how many more do I need to make 10? Also, make sure you're interchanging numbers as students change their focus. They don't start with learning with the number 10. In this unit, they actually start with the number 6. So making sure we're asking the correct number is important. A student example answer might be, I needed 8 because if I count 3 more, then that puts me at 5, and then I only need 5 more to make 10. This is not the only way a student could answer. They could answer in multiple ways. They could answer by showing you how to count up as well, maybe by using their 10 frame, by showing how many empty spaces are left on their 10 frame. Another example, what's another way to make 10? A student could say, I used 2 and 8 for what they used, and then another way could be, I made 3 red counters and 7 yellow counters. And then the last one, how does your 10 frame model help you make 10? Again, there could be many ways that students could answer this question. But again, a possible answer is because it helps me see how many more counters I need to fill up my 10 frame to make it full. So student demonstrations and explanations could demonstrate MTRs 4, which is engage in discussions that reflect on math thinking of themselves and others. MTR 5, which is use patterns and structures to help understand and connect math concepts. And MTR 6, which is assess the reasonableness of solutions. Students can further their learning at home with a guardian or sibling or even a friend in fun ways. This learning activity is taken from the STEMscopes parent letter. Here, students can play the I Spy game with a fun mathematical twist. One person decides on a number and spies something with that particular number. That person can give hints such as including a color if needed. The guesser then counts various objects until they find something with that particular number. Then each of the players switch. Finding math around the home in places other than school can be fun. So, for example, if you have a toy bin that looks like this in this picture, somebody could say, I spy something that has the value of 8 in the toy bin. And then the guesser would try to find 8 of something. There could be 8 eggs. There could be 8 stuffed animals. But in this instance, the guesser is actually thinking of 8 tires on the train cars. So again, if we had to give a hint, I'm thinking of something that has a value of 8 and it's yellow. That might guide the student into thinking more towards the yellow tires in that picture or on their toy shelf. And then the student would say, I see 8 tires on the train cars. Now it's my turn to spy a number. And then you would switch. So even though students are not at school, these would support MTRs 3 and 7. 3 is complete tasks with mathematical fluency, and 7 is apply math to real world concepts, which we're always looking for. I hope this video is helpful with what one might hear and see within a kindergarten math classroom during composing and decomposing 10. Remember to be on the lookout for the next exciting best practices video coming soon.